Often programs are used to perform many calculations automatically, so someone doesn't have to prompt the computer at every step. For this we use loops. They are the building blocks of programming and will repeat a sequence of calculations for as long as you need. All you have to do, as a programmer, is give the conditions under which the loop should run and then write the code. Easy. As this is a fundamental part of programming, it's worth taking the time to practice. In this video we will cover for loops, if statements, and while loops. First we'll explain exactly what a loop is and how it works. The for loop executes a series of commands which repeat themselves. The exact number of repeats is the first thing you specify when writing a for loop. The loop keeps track of the current iteration with a counter, which is a vector running from 1 up to the number of loops that you need. Once inside the loop, the script will run until it hits the command end, which signifies the end of the current loop. At this point, the script goes back to the beginning and the counter increases by 1, or rather, it moves on to the next value in the array. Then the calculations start again. If the counter is at the maximum value when the loop reaches end, then the script moves on to the next line of code after the loop. For practice, let's take a problem that we can already solve and see how it could be done with a for loop. Let's take the vector x, which is the vector running from 1 to 10, and add 3 to each element in a loop, so we will get the same result as x plus 3. We are going to write our loop in an M file, so we can easily make any changes if we want to. Enter the vector x. On the next line, open the loop. This line means that loop will run once for every element in x. The counter starts at I equals 1, so in the first iteration the line will take the first, or ith, element of x. Remember that an array, followed by a term in brackets, indexes that element from the array. As we want to alter the value of this element, we continue typing on the same line to make the change. This code takes the currently selected element and adds 3 to it. The number now overwrites the old value of I of x, so in the first iteration the number 1 becomes 4. This command closes the loop. In the first run, I equals 1, so line 3 takes the first element of x, which is 1, and resaves it as itself plus 3. Now we go back to the beginning of the loop, and I equals 2, so line 3 takes the second element of x, and again resaves it as itself plus 3. This continues for 10 runs. It works, but notice that each iteration of the loop was printed to the command window. For large programs, this could get very messy, so be sure to suppress your code, even if it is in a loop. We'll also get the script to print the final answer once it has been calculated. So our loop works, giving the value that we expected from the direct calculation. You can also see that it didn't print every loop.
Sometimes you may be required to perform checks on the entries of an array. That is, examine each element and decide whether or not it obeys certain constraints. We can use the indexing technique that we practiced in the previous example. Once the element is selected, MATLAB then needs to compare it to a condition with an if statement. This allows you to supply MATLAB with instructions as to what to do with the element based on whether or not it satisfies the given condition. Conditions are made with the logic operators, which can be viewed in the help for if. Let's try an example. Say that we have been given an array of random numbers between 0 and 1. We want to turn the array into just zeros and ones by rounding the numbers to the nearest integer with an if statement. First, input the random array. This produces a row of 10 numbers between 0 and 1. Again, we open a for loop and set it to run 10 times. Instead of using the length function as before, we write the figure 10 because we know that the loop needs to run 10 times. Now we implement the if statement. If the number is greater than or equal to a half, we resave this number as 1. This loop will round numbers greater than a half up to 1, but what about those less than a half? We need another if. This second statement will round those numbers down to 0. But don't forget, we need to close the overarching for loop and also display the result. Let's see if the loop works. It does, but there is an alternative and more efficient way of writing it. The final if statement is superfluous if you have the ability to say, if this is satisfied, do that. If not, do this. If not in MATLAB is given by else. Let's rewrite the loop so it only has one if. Now the loop examines whether or not the number is greater than or equal to a half, as before, but instead of then opening up another condition, it knows straight away what to do if the original one is not satisfied. As always with MATLAB, there are different ways to achieve the same goal. In this case, we could have used the rounding functions ceil and floor. See if you can change the above script to use these functions instead of stating 1 and 0 explicitly.
The final loop we will look at is the while loop. While bears similarities to both the for loop and the if statement. It's a loop, but instead of being initialized with a counter, like the for loop, you use a condition. If this condition is always satisfied, then the loop will run forever in what is known as an infinite loop. To terminate it, press Ctrl C on the keyboard. You can also use this to stop functions. To demonstrate while, we will create a script which gives the multiples of a given number up to a maximum value specified by the user. For this, we will need a counter which we set before the loop begins. The loop will run until the multiples of a exceed the maximum. Then, before the end of the loop, increase the counter by 1. So to reiterate, set the counter to 1 before the loop starts. A is the multiplication table that we are interested in. Max is the largest value you want to go to. Open the while loop with a condition. In this case, we want the loop to run until the multiples of a reach max. Create a variable x, which is where the multiples of a will be saved. Increase the counter by 1. Remember to end the loop. The loop starts again, but now counter is equal to 2. While loops are useful tools for their versatility. They can be used both as a for loop which executes a predetermined number of iterations, but they can also be used in certain situations where you do not know how many loops it will take. For instance, finding the largest number which satisfied a certain condition, or finding how many loops a certain process will take. This video has covered the topics for loop, if statements, and the while loop, using simple examples, but MATLAB can be used to solve much more complicated problems.